Good morning to all. Now, this session is in continuation with the previous session where we started time variant and time invariant systems. So, we discussed how to analyze or how to recognize whether a given system is time variant or not. Now, in this session, we are going for another example that supports to recognize a system is variant or not. Let us start. So now just we started time variant or time invariant. Now in the previous session we started with time variant. Now we are going to give a good example that supports time invariant system. Again I am telling you whether it is time variant or time invariant. Two important steps students have to follow. One is for as per the definition. Second step is as per the substitution or put substitution. So these two steps you have to remember. Whether y of t minus t naught, introducing time delay. What we have to get? Y of t minus t naught, because delay means what? Negative. If this is equal to this one, this is called time invariant. If y of t comma t naught is not equal to y of t minus t naught, this is called time variant. So remember this one. Again I am representing this one. This is called time variant. Now let us start. Verify. A given system y of 2 equal to 2 times x of t plus 3 times t. The given equation A. Verify whether the system is variant or time invariant. Now just look at the substitution or time variant. Substitution means what? Where do you mean it? Substitution or definition should be in functions only, not single time variable. Look at definition and substitutions put are in functions, in function of t only, in function of time only, but not in individual t, Look at a point. So the substitutions or definitions should be applicable, should be applied only in functions of t, not individual t. Look at here, t is a function of t. Here you have to make it. Here t is not any function of t, individual variable. So here we should not apply anything. Now just look at. Substitution should not be applied. Now just look at first one as per the definition. As per the definition. Now just like introducing a time delay t naught. So with the existing time t, introducing time delay t naught. T naught is equal to 2 times x of t minus t naught. This is definition. In the definition we are applying 3 times t minus t naught. This is equation 1. Look at. Again I am telling that substitution should be in the function of time only, but not in the individual t substitution. But definition should be both in definition apply. Definition is applied to all t definition is applied to all t. Wherever there is t, replaced by t minus t naught. That is according to definition. But regarding substitution, t should be replaced by t minus t naught only in the function of t, but not individual t. These two things students have to make the distinction between these two. Now this is according to definition. So in the given equation, wherever there is t, you are replacing t minus t naught. Now we are going for substitution. So substitution should be where to be substituted. Wherever there is a function of t, there only we have to substitute. So here y of t minus t naught, that is equal to 2 times, look at the given function x of t is a function of x, so replace by t minus t naught plus 3 of t is not a function of t, any function, it is individual t. This is signal, this is only time variable, this is signal, x of t is a signal, t is a time variable. So in time variable you cannot make any substitution, t remains as it is, same, t is constant. So here this is equation 2. Now just look at here, this mathematical modeling of a given signal is for verifying whether the given signal the given system belongs to either time variant or time invariant. In the previous case, we given two modelings of signals. So there we directly substituted wherever there is t, it was replaced by t minus t naught. But here just look at the given signaling is how the signal is modeled. Y of t equal to 2 times signal. X of t is a signal. In the previous class I told you everything. X is the name of the signal. Parenthesis gives what? Function. T is what? Individual variable. So entire x of t is called a signal. But here t is only time variable, not a function or not a signal. It is a time variable. So here t should be replaced by t naught, t minus t naught, according to definition. But regarding substitution, we should not substitute here t by t minus t naught, because this is not a signal, it is only time variable. Now just look at same thing I did. Just look at, for verification, 2 steps you have to make it. First step is definition step, second step is substitution step. In the definition step, as per the definition, wherever there is t, it is replaced by t minus t naught. But in the second step, wherever there is a signal, there only we have to substitute. If t happens to be an individual time variable, we should not substitute. The same thing is did. Now just look at, now compare. Now compare these two, 2, x of t minus t naught, x of t minus t naught plus 3, t minus t naught, here only 3t only. Now look at, in the last term these two are differing, therefore equations 1 and 2 are not same. These two are not same. Not same means what? These two outputs are differs to each other. Therefore, what is happening? That means what? Y of t minus t naught not equal to y of t minus t naught. Therefore, the system is what? Therefore, the system is time variant system. Time variant system. Time variant system. Therefore, the system is time variant system. Now again I am telling regarding the systems. Now under this topic, systems can be time variant and time invariant. How to distinguish between time variant and time invariant? For these two, take any system. For any given excitation, if the getting response is same irrespective of time. At any time, if you execute for the same input you give, the same output it is giving, then the system is not changing with respect to time. Therefore, this is called time invariant systems. Time invariant system. In real life, we need only time invariant systems, not time variant systems. In only specific cases only we need time variant system. In medical diagnosis, in medical ICU, if any patient is joined ICU, they have to observe the fluctuations of heart or mind or body fluctuations regarding BP, sugar, etc., how the fluctuations are taking place. There only we use time variant systems. In most of the cases we use time invariant systems. This is very much important. So here one important point. Whether it is time variant system or time invariant system, students have to observe. Again, I am remembering you, T, introducing a delay. The output is T minus T naught. At any time, if these two are equal, that means what? Time invariant system. If y of T naught is not equal to y of T minus T naught, this is called time variant system. So the one important word that is called in time variant and time invariant. In time invariant, only single word is dominating. That is called what? Time. If time, single word. If time is changing every time, excitation inputs are changing every time, excitation responses both are changing every time, this is time variant. If they are not changing, they are fixed, giving correct response to the correct excitation, this is called time invariant system. So this is the difference between time variant systems, time invariant system with respect to time domain. So again, one more time I am remembering you regarding static and dynamic system. The dominant word is called memory. Regarding casual and non-casual system, the word is called future response. Regarding time variant and time invariant systems, the word to remember is called time. These three are very much important for students to understand, to make a clear-cut difference among these three operations. For any kind of operation, they always give a mathematical equation, modeling, signal, it will be given. For the given signal only, we have to verify whether the modeling system belongs to static or dynamic, or casual or non-casual, or time variant or time invariant system. These three are very much important in visualizing and analyzing the systems. Thank you. In the next session, we are going to discuss another topic.